So in this example, what we're going to do is we're going to look at something that we call a sequence. So we're going to look at something that we call a sequence. A sequence is really just a list of numbers in some order. Now, let's look at some sequence like here's my sequence. Here is my sequence of numbers. Here's my list. I'll start at 11. Then I'm going to go to. I don't want to trap myself by using the same patterns again and again. So let's not start with 11 actually. Let's start with 15, and let's go to 10, and then 5, and then 0, and then -5, and so on. And let's just say it continues. So here's my sequence, and I could write a list of which term number each of these numbers is. So here, these are all different terms. 15 is a term, 10 is a term, 5 is a term, 0, -5, -10, they're all terms. So 15 I could call term 1. 10 I could call term 2. 5 I could call my third term, and so on. So what I want to do with this particular example is write an equation that describes the relationship. So the relationship between the term number and the value of that term. Okay, so to do that, we can look at y equals mx plus b as this sort of basic general linear equation that could describe any kind of linear relation that we throw at it. What do we need to choose here? We need to choose an m value and a b value. And to do that, it might actually be helpful to list these corresponding numbers in a table of values. So let's do that. So when we have our term number, here we could say term number is, when our term number is 1, the value of that term, what is the number value of term 1? It is 15. For term number 2, what is the value of term 2? It is 10. What is the value of term 3? Well, it's 5. And so on. And that pattern continues, right? So term 4 is 0, term 5 is -5, term 6 is -10. Now to get to each new output value, to get to each new, you could call it each new y value, or you could call it, to get to each new value in your list, it looks like we have to subtract 5. And to get from 5 to the next value, which would be -5, to get from 5 to the next value, which would be 0, we would again -5. So what are we repeatedly adding? The repeated addition to get to each new value is 5, but it's negative. So what is repeated addition? Repeated addition is really multiplication. So our multiplier is going to be -5. You could try to remember m as your multiplier value. We will eventually call it something different. So our multiplier is -5. And we need to know what this other parameter, this constant that we should add, should be. So one way to do this is in the ways that I've shown in the previous examples, but I want to show you a more powerful way. I want to show you a more powerful way to find this b value. So I'm going to make some room. Now, here is the equation that I have so far. Y equals negative 5x plus b. And I want to find out what my b value should be to describe this situation. So what I can do is I can plug in a value of y and a corresponding value of x that I know exists, and then I can solve for b. So let's do that. I know, first of all, I know that when x is 1, y is 15. So when x is 1, y is 15. And then I can just fill in the rest of the equation. I can see that b is actually my only unknown left, and I can figure out what it must be. So simplifying here, we have 15 equals negative 5 times 1 is negative 5. I want to know the value for b, so I can add 5 to both sides. And I see that b must be 20. So that's a more systematic way to find that constant that you should be adding. So we see that the equation that describes this linear relation is negative 5, which is our multiplier, times x, plus 20, which will be our constant. And this particular equation, if you plug in, I want to be clear about this. If you plug in the term number into x, what you should get out as your y value is the value of that corresponding term. And this equation would be able to give that to you. So that's the power of this particular equation. We started just by looking at a sequence, right? Just a list of numbers in some order. We found a pattern to this sequence, right? We are decreasing by 5 every single time. We related the position of each of these values to the values themselves. So this was position number 1 in the sequence was value 15. Position number 2 in the sequence was value 10. Position number 3 in the sequence had a value of 5, and so on and so forth. And the relationship between the position in the sequence and the actual number value of that term is completely described by this equation. And we don't have to use x and y here. The only reason I'm using x and y is hopefully that we can eventually get used to using these variables when we're graphing. But your workbook, for example, might use different variables here. Your workbook might actually use variables that look like this. So they might use the value of your term is equal to negative 5 times your term number plus 20. Or they might choose to label them differently. Sometimes we often use n here. We often use n as our variable to describe the term number. And it is convention that you will eventually get used to in future grades. It is convention that you will eventually get used to see the value of that particular term as a sub n. And we call that the value of your general term. It's all sort of specific vocabulary that you don't necessarily need to know for now. But please feel free to just use x and y as our independent and dependent variables. Hopefully that's all clear, and we will do another example in the next video.